Alright, so we're going to get started on some of the performance calculations that we're going to need to know as we start building towards our case studies. And the reason we need to know these is from the standpoint that if we are going to be evaluating a feeding scenario, we need to understand how to measure performance in that feeding scenario to determine if it is profitable, not profitable, or to be able to make good decisions. And so it's kind of one of those things. Without good data, we can't make good decisions. So we're going to walk through some examples. There's two readings that you're going to need. There is the University of Kentucky Livestock Calculations handout that is on Blackboard Learn. And there is also a feed cost per pound of nutrient handout that I put together that's going to help us with evaluating feed costs. So those are the two supplemental reading that you're going to need for this activity. We're going to work through a couple different problems to provide examples for you of how to do these calculations. And so what we're going to do is walk through the swine situation, which I give names to all my scenarios, which happens to be Barry Bluebutt. It just makes emails and conversations so much more fun than saying the swine scenario to talk about Barry Bluebutt's swine operation. And so as we go through that problem, there's some pieces of information that we need. When you read it, you find out that Barry Bluebutt has a group of 250 pigs. That sounds like something we may need. They weigh an average of 40 pounds. Okay, beginning weight. And he paid $83 per pig. Okay? So he fed those pigs an average of 105 days, and I call that days on feed. And sometimes you'll see me use acronyms like days on feed, DOF. And their final weight at market was 275 pounds market weight. Okay? During that same time period, each pig ate about 630 pounds of feed. That cost $10.90 per hundredweight. Alright, that gets us the bulk of the information that we need to be able to solve these problems. Problem A for Barry's operation is asking about what we call average daily gain. Again, that's one that I do an acronym called ADG a lot of times to keep the shorthand, because writing that down a lot gets pretty old. An average daily gain is simple: the total gain in pounds divided by the days on feed. So for this problem, our total gain, we know that pigs started at 40 pounds and they finished at 275. So that difference is our gain. How much did they gain from beginning to end? And we know that our time, or days, is 105. That was given to us in the problem. So if we were to solve that, 275 minus 40 should be 235 pounds gained, divided by 105 days. That tells us that these pigs are gaining 2.24 pounds every day. And that's pretty good for a pig. So that's kind of what we're wanting to do. So that's the first one, is just figuring out average daily gain. The total gain divided by the days on feed. The second problem is looking at feed efficiency. Or you'll sometimes see feed conversion. A lot of times this is referenced as feed to gain. And what this represents is the pounds of feed fed divided by the pounds of total gain. So in this case, we know that Barry's each pig ate 630 pounds of feed. That was given to us. We divide that by the total gain, which we calculated in the last problem. But just to set it up, again, that's the ending weight minus the beginning weight. So 630 pounds of feed divided by, parentheses, 275 minus 40 equals 2.68 pounds of feed for 1 pound of gain. So the nomenclature for that would be to write 2.68 to 1. It's kind of like a ratio. But just so you know, on Blackboard, when you submit this, these are the values you're going to enter to determine if they are correct or not. The third problem for Barry is looking at the feed-only cost of gain. And so what we need to do is we're going to figure out how much it costs to feed those pigs and then divide that by the total gain. Which makes sense. If we know how much it's going to cost to feed a pig, can we reduce that feed cost and still see the gain that we want to see? That is going to help be an indicator of if we're being profitable or not without affecting animal performance. Okay, so to get to total feed cost, we know they fed 630 pounds. And that feed cost was $10.90 per hundredweight. That is the same as 0.109 per pound. So if we simply multiply times 0.109, basically 11 cents a pound, and divide that by the total gain, 275 minus 40, then we're going to get our feed-only cost of gain. So 630 times 0.109 is 68.67 for feed cost, divided by 275 minus 40 equals 29 cents. So for every pound of gain, it's costing almost 30 cents to feed that pig. Alright, the next is actually the break-even price per pound. And the break-even is going to be the feed cost plus the beginning value divided by the sale weight. Okay, not the current weight, the sale weight. And so what we're doing with this is we're figuring out the bulk of our costs. Now realize that if we were truly in a production operation, we may have things like labor, overhead, yardage, health care, other things that go into this total cost up top. But for this class, we're just going to worry about feed costs and beginning value, and then divide that by the sale weight. So in Barry's case, we just solved that it was $68.67 for feed. That was what we did in the previous problem. And we know that he paid $83 per pig. So it cost $68.67 to feed a pig, and the beginning value of that pig was $83. And so if we were to just put those two together, the total feed and value is $151.67. Okay, so that's going to come in handy in the next problem, is why I always kind of jot that down. Now if we were to just take that value and divide it by the sale weight of 275 pounds where he's marketing them, that means he has to sell them for 55 cents a pound to be able to recoup his costs. That is per pound. Okay? So that's what he has to do. He has to be able to recoup this much money off those pigs, and that equates to 55 cents a pound. If I were to ask for hundredweight, you would go out to 2 decimals, and that would actually be 55.15 per hundredweight. If you look at the calculator and you can see, sorry, get to where it's not blurry, 55.15. Okay, so that leaves us with the last couple of questions about the feeding margin. And the margin is basically your profit or loss. Okay? And so what this question, when it's asking if the animals will average $62 a hundredweight at market, what's the feeding margin for all animals? Okay, so are you making money or losing money? And immediately you should be like, okay, if I'm selling for 62, that's greater than 55, I should be making some money. The question is, how much? So we're going to take and figure out our sale price, 275 pounds times 0.62. That's the $62 a hundredweight. That means we're really making $170.50 per pig. Okay. And so we know that our break-even price per pig was this value right here. So for a margin, we're going to subtract the difference. And that difference is $18.83 per pig. And that's profit. The question is asking for all animals. So if we multiply that times 250 pigs, then we see that that is $4,707.50 profit. This number can be negative depending on the situation, and so that's how you can take a look at your feeding margin. $18 a pig doesn't sound like a lot, but when you start multiplying it over a couple hundred pigs, then it shows a little bit more profitability. So again, the numbers that you would be inputting is this value here and the price per pound up here for the break-even. And that's how you do these performance calculations. You've got a lamb one and a beef cattle one to work through. Next video we'll do the dairy example. Alright, the next type of problem that we're going to look at is the income over feed cost, which is for dairy problems specifically. And that could be any kind of a dairy operation, sheep, goat, cattle, doesn't matter. And there is one caveat with income over feed cost is it's a reasonable number, but sometimes it does have that relationship with performance as well. And if you focus too hard on the income over feed cost, you can actually drive production down. So just as we look at this number for evaluating performance and feed cost, it is one tool. And so some dairies are also looking at total profit per cow. And so there's a couple different tools, but we will go ahead and take a look at the Holly Holstein problem. And so that's the second problem on the sheet. And basically when we're dealing with the income over feed cost, IOFC, that's the acronym, it's basically your profit per cow. It's the income per cow minus the feed cost per cow. And that is IOFC. So when we take a look and read this problem, we see that Holly has a group of dairy cows that are averaging 80 pounds of milk. And that milk is valued at $14.44 per hundredweight, which is also the same as 0.1444 per pound. Okay, if we divide by 100. Okay, then we know those cows are eating wrong number, 55 pounds of dry matter per day at 15 cents per pound of dry matter. So if we were to take a look at this and take the 80 pounds of milk times the price on a per pound basis, we see that they're profiting or making $11.52 per cow. The feed cost, 55 pounds times 0.15 cents, costs $8.25. So if we take the difference, subtract those two, oops, typed in the wrong numbers, we see that there is a profit, it's positive, of $3.30. That is the income over feed cost for Holly's Dairy. So when you think about it just as that income per cow minus the feed cost per cow, it's a pretty simple number to calculate. And it does show kind of that relationship between feed value and milk production. But it is one to use with caution, but it is a tool that dairies use to evaluate their profitability from a feeding standpoint. The next video is going to take a look at the estimating feed cost per pound of nutrient. Alright, the last type of problem that we have on this homework is looking at the cost per pound of a nutrient. And so this is generally used when we're looking at making feed choices. Like, what feed for protein do we want to put into a ration? Or how do we want to view these different feeds? And so what we're going to do is we are going to price 3 different feeds. We are going to do from 3 of the different problems. For roughage, we are going to do the example of corn silage. For energy, I am going to do the barley, oops, and this is for the megacals of net energy. And then for protein, we will do soybean meal. Okay? So what we're going to need to do first and foremost is gather the data for these feeds. And so for the roughages, we're just going to do a cost per pound of dry matter. For the energy feeds, sorry, pulling it up on my computer, we're going to do a cost per megacalorie of net energy for maintenance. For protein, it's going to be cost per pound of crude protein. Okay, so we need to get the following information from each feed. It's going to be the dry matters for all the feeds, and then specifically these nutrients. So, if I grab my handy dandy textbook and we go to table 1, and you'll notice I've flagged where the tables are at because it makes it easier and faster to find them. And our first feed is corn silage. And double check your IFN numbers, but it's this well-eared corn silage. They're 3-28-250, and it is 33% dry matter. So for roughages, that's all we need to know, is that it is 33% dry matter. Now for the barley grain, we need to know the net energy for maintenance and the dry matter as well. And so come down here and find barley grain. We need the one that is 4-00549, 88% dry matter, and 2.06 megacalories per kilogram. Okay, now for protein, we need to find soybean meal, which is under the S's. And soybean meal, we need specifically the one that ends in 637. So 89, and the protein value is 49.9. Did I just write that down wrong? I feel like I did. We're going to double check it real fast. 89. Yeah, and it never hurts to double check your values. Okay, always double and triple check your values. It will make your life easier. So basically, when we're setting up these equations, the corn silage, its price per ton is $45 for 1 ton. That's the same as saying $45 for 2,000 pounds. But what we really want to pay for is the dry matter. So we want to know what that cost is per pound of dry matter. So we're going to multiply the weight times the dry matter to figure out what that is. So if we were to solve that, divided by parentheses 2,000 times 0.33, we learn that we have 660 pounds of dry matter, and that cost per pound of dry matter is 0.07 cents. Now when you do the alfalfa hay and almond hulls, you'll be able to see how this compares to those other two feeds. But that's what we'd be paying on a pound of dry matter basis for corn silage. Now for the barley, it's going to be the same principle, except barley price is given to us as $9.45 per hundredweight, which is the same as 9.45 divided by 100 pounds. Okay, but that is as fed. So we need to figure out how many pounds of dry matter is in there. So 100 times 0.88. That's going to give us the dry matter. And then we also need to know how many megacalories per pound. So remember, this is megacalories per kilogram. So we need to take that number divided by 2.205 to convert to mcals per pound. So let's do that first. $93. So now we know that we have this amount of dry matter. We're going to just simply multiply times the calories, the megacalories per pound of dry matter, to get to what our answer should be. So it should be 9.45 divided by, let's do that bottom end first, 81.84 mcals. So the price per pound, or price per mcal of barley is 9.45 divided by 81.84. And that is 0.12 cents per mcal. That is what you would be putting in to Blackboard. Okay, so just remember the book puts it in kilogram and you have to do this extra step. Okay, so to figure out the price per pound of protein in soybean meal, our soybean meal price is $360 per ton, which is the same as $360 per 2,000 pounds. And so we want to know what that cost is per pound of protein. So we know that it's going to be 2,000 times 0.89 to get to dry matter. And then we need to figure out how many pounds of protein is also in that. So that's going to be 2,000 times 0.89 times 0.499. Okay, that's 888. So if I store that, now we can take 360 divided by that answer, and we get that it is 0.41 cents per pound of crude protein. And we will see that protein is going to be our most costly feedstuff compared to these others. So just kind of as a review to help clarify this, if I was buying in, don't laugh at my semi-truck drawings here, okay? So if I was buying in my truck and my feed, okay? A load of feed. The first thing I want to account for is water, okay? Pull out the water and then know how much dry matter am I dealing with. Then I want to figure out how much of the nutrient is truly in that truck. Because if I'm buying in a load of soybean meal for swine diets, I am paying for protein. I could care less about energies. I want to know my cost per pound of protein. And so that's why, to figure that out, we simply take the weight times the percent dry matter on a decimal form times the nutrient concentration on a decimal form. Okay, so that's either per pound or move the decimal. And that's all it takes, is you do all of that and you just take the cost divided by that. So if it's cost per hundredweight, this value would be 100. If it's cost per ton, this would be 2,000. If it was cost per pound, this would be 1. So it can be a variety of things to solve for that. So go ahead and take a stab at the rest of those problems. Just a note, the almond hulls, you need to look up in the Noble Feed Library, which has a link on the side menu for the Noble Library. Okay, because it's not in the textbook.